Hello, welcome to section 2.6 on diagnostics and just random graphs, not just parabolas. So how do you find the diagnostics of any given graph? Well, before we get into the nitty-gritty, I want you to have a note card that talks about some different positive and negative notation. So it is important that you're aware of ways you can be asked if a graph is positive or negative, other than just plainly stating the words, is that where, or asking, okay? Where is it positive? Where is it negative? So in the orange color, you could be asked this: where is f of x, which is the graph, greater than 0? That means where y's are positive, where y's are greater than 0. So that is really just asking, where is it positive? In the green, they could ask, where is f of x greater than or equal to 0? So this is different than what you're used to. This would be, where is it above the x-axis, but also on the x-axis, equal to 0? Because remember, f of x is like y. So where is y greater than or equal to 0? So this includes your x-intercepts. And you would use square brackets on the x-intercept. And then the blue, oh, there we go. If it asks, where is f of x less than 0, that just means where is y less than 0, where is y negative. So that's just your typical where is it negative. And then the purple, where is f of x less than or equal to 0, that's asking where it's negative and on the x-axis. So let me show you an example. This is not a parabola, this is actually a cubic, and you get more into that when we get into math 3, but you still need to be able to diagnose this graph. So if you look at this graph, it's going like this. Where is it greater than 0? And I correlated the colors so you would know. Oh, pause if you need to and finish up this note card. Sorry, I just moved on. Pause and finish up note card 65. All right, and here's note card 66, which is an example. So I correlated the colors, the orange, so you can go back and look at this, but I also put it right here. This just means where is it positive? Now remember, you go left to right and you notate with x values. So it's positive from -2 up to 0, union 2 to infinity. Because if I were to smush those down, that would be the interval notation. Where is it greater than or equal to 0? This means where is it positive and on the x-axis. So you just put brackets on the x-intercepts. In the blue, where is it negative? That's what that really means. So it's negative down here and here. So this is negative infinity up to -2. And this one's from 0 to 2, like normal. But then if I add the equal to on there, you just put brackets around the x-intercepts. Now I'm going to go to Delta Math, where I will pick some of the questions that you might see on this assignment, and I want to look at them with you. All right, so this one, find the domain. Now they're going to ask you answer type. You need to use interval, okay? Now this one is really wonky, and I really didn't know that it was going to have one like this. So let me think if I want to keep that. I think you could do it if I were to smush. This is an asymptotic behavior. I know you've never heard of that, but this is asymptotic behavior. And this thing is getting closer and closer to this x line of -5, but not hitting it. So if I were to smush that, that would be negative, oh, there's a negative infinity option, comma, up to -5, but it's not actually going to hit it. Oops. Wait, I guess I have to do this. Okay, negative infinity, -5. And then we're doing domain here. So a union, move my face. And then we're acting asymptotic here at 3, so it's not actually going to hit that. So it picks back up at 3. And then towards infinity. So that one was tricky. These are asymptotic. I don't know if you're going to get to one like this, but when you see this, I call these branches, and they're getting closer and closer to that x value right there, but not touching it. So we hit submit, keep our fingers crossed, and that's correct. And they talk about the asymptote. And I know we haven't done that yet, but I think y'all will be able to be just fine on that. I wanted to do a different graph, so I backed up a little bit and started recording again. All right, so this is a graph of what's the domain. This thing stops here at 1. It doesn't keep going this way. So if I were to smush this down, the domain would start at 1 and go to infinity. But that 1 is included, okay? So that would be a bracket on the 1. So it'd be bracket 1 and then infinity. Make sure you're choosing interval notation, okay? Now, let's look at this one. This is another one that has an asymptotic behavior, and you go from left to right. So this is domain. It's going up to -3, but not hitting it. It's jumping right back up there, but you can't include the -3. That's that asymptote thing. Even though we haven't learned asymptote, you should see that this graph is not all real numbers. It splits at -3. We don't actually hit that. So we're going to do negative infinity to -3, union, and you pick back up at -3 and then towards infinity. Now, because you may get to some of these, I'm actually not putting a penalty on this section. So if you want to, you can just you can pass through go past the asymptotic ones if you want. So let's see. There's another asymptotic one. Let's see. Go here. Oh, some more. I mean, I still think you should be able to do it. Let's look at this. This would be negative infinity up to -7 union 5 to infinity. All right. Oh, yes. So, yes, I am removing the penalty, like I said earlier, but you should be able to do this. Looking at these, you should definitely be able to do those. I know it's weird. I'm going to take this penalty off for you. Now, I want to look here at increasing and decreasing. So this says the function f of x is graphed below, and I think you may have seen some of these before on Delta Math. What is true about the graph on the interval x equals negative infinity to a? So what's happening from x values that are tiny up to a? That would be increasing. Oh, so I know it's either going to be A or C, and it's also negative. Is that my answer? Fingers crossed, we're good to go. So those I think are going to be easier, and you've seen those before. Let me go on to this one. All right, so here's where it's going to use the new notation that I went over with you here. Okay, so it says, where is f of x greater than 0? Guys, that means where is it positive? This thing's positive from -7 to -3. It does not have the equal to on it, so I will not use brackets. All right, this one says the word positive, you know, that does too. This would be where is it negative? So where is it below? That'd be between -7 and 3. I'm not sure that you're going to see any with the equal to's on it here, but I just wanted to show you that. All right, next, it says, what is the domain on which the following function is increasing? That just means where is it increasing, guys? This thing is increasing from this x value of 1 all the way to infinity. Oh, my picture. All right, let's see if we can find any weird ones. I don't know about that. Where's this increasing? Okay, I did want to go over one like this. This does not go on forever. See, it's got those dots there, so that means it ends, it stops, okay? So what is the domain of increase? Well, that's from 0 x value right here up to this this x value of 6. So it's increasing from 0 to 6. So you're not going to have infinities on here because it's bounded on both sides. So 0 to 6. And again, I want you to use interval notation. And it shows me there. I really like how Delta Math shows the increasing. There's another one like that. Let's see. Yeah, so just see, this one is asking where it's decreasing and it ends there. So it's decreasing from 6 to 13. And remember, with increasing and decreasing, we don't use brackets because you can't increase or decrease at an actual point. Just saying. Okay, so I wanted to go over that. And then this is the level 2 of this. Yes, it's wonky. I know. Look at that fun graph. I like it. Okay, so look at this one. It says determine all intervals on which f of x is greater than or equal to 0. I am actually going to pause myself and I'm going to put this as an example on the notes. Hold on. We'll be able to see where I put that on the notes here in a minute, and we'll do another note card. Determine all intervals on which f of x is greater than or equal to 0. You guys, greater than or equal to 0. Greater than or equal to 0 means where is it? I know you can't see that, but it means where is it positive and on the x-axis. So where is this thing positive? Well, left to right. So it's positive from negative infinity to 2, but you will include the x-intercept, so you'll put a bracket there. So we're going to do this right there. So negative think sometimes it has negative infinity and sometimes it doesn't, which is really weird. But negative infinity up to 2 with a bracket because this has an equal to on it. Now we have another spot where it's positive from 8 to infinity because if you switch it down to the x-axis, but the 8 would need to be included. So I need to pick this one. So it'd be 8 to infinity. So much fun. Hit submit. Keep your fingers crossed. Yes, 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 yes. All right. That was fun. I'm going to go put that on the slide and I'll be right back. Okay, so this is note card 67. It's going to be a lot of fun looking at your note cards and seeing how you guys draw this, but I do want you to draw it. You got to get used to that, but this is where it's asking where it's greater than or equal to 0, and we just answered it on Delta Math, but I want to have it here for you. So go ahead and start working on this note card. I'm going to go and like box in that answer nicely. Oh, yes, look at that. Make it transparent, and then I'm going to make, you know, because I'm extra, and change the color to this fun greenish. No, I want to do this greenish color. Okay, so anyway, we just went over it, but I want you to have a note card with it, okay? So pause me and finish up this note card. All right, so back to Delta Math. Back to Delta Math. Back again. I want to go to a new problem. And this one's asking, again, where it's greater than or equal to 0. So where it's above the x-axis, but also includes the x-intercept. So it's above the x-axis, every -8 and beyond. Okay, so if I smush all that to the x-axis, it would be bracket -8 and on forever to infinity. Okay. All right, and then we've got this section's relative extrema, and it says, this question says, and extrema is just max and min. How many points on this graph represent a relative minimum? Meaning there's a low, a valley. So there's one here, one here. So my answer would literally be 2. Point B and point F would be a relative minimum. Okay, and it goes over it. And then right here, how many points on the graph represent a relative maximum? B does, C does not, and F does. So there's 2 again. Okay. What about a relative minimum here? There's 2 of them. So that's that one. And then a visual domain and range. Yes. What is the range of this one? What is the range of this one? Remember, range is the weird diagnostic where you smush to the y-axis and you go from bottom to top. So if I were to smush this blue curve that's bounded on both sides, it's bounded above and below too, there's not going to be any infinities. If I were to smush this to the y-axis, it looks like my lowest y value would come from this, which is -1. And then my highest y value would come here, which is 4. So it's from -1 to 4 included. So it'd be like this with brackets. Okay, so my answer, keep my fingers crossed, and look how they do it, how they explain it. They've got that little blue area, that's the range. The minimum is -1, the maximum is 4, and they talk about it being a closed circle. Again, I want you using interval notation. So what's the range of this one? What's your lowest y value? Would be 0, and what's your highest y value? It would be 5, and it would be brackets. So 0, 5, and we're good to go. All right. And that was the last section there. So hopefully you guys are rock solid on this and you understand that you can still do diagnostics with any graph. I think the weirdest ones were those asymptotic ones. And again, that has that section, which was section, oh gosh, I can't move this around so you can see it. Okay. Which was this finding the domain graphically. I have no penalty, so when I do that, you guys can just click around to problems that you can click past those asymptotic ones. But I still would like you to try them. You guys have a great day.